Hi all, welcome to part 5 of the video lecture on database management system, particularly the DR modeling. Okay, so in the previous 4 parts we systematically developed the way of visualizing the DR diagram. Started with what is entity, what is attribute, different types of attribute, and how to draw it. So that is the way we proceeded. Now here we will see something like value set or domain of an attribute. Entity type and entity set, hope you remember. Now this is a different terminology called value sets. So these are all basic things only, but sometimes they can specifically ask you what is meant by value set or domain of an attribute. So that time you should know, you should be able to write it without any confusion. That is why I'm explaining all these minute terminologies. Okay, so it's a very simple thing. If you are looking at the attribute, say age attribute, what are all the possible values this age can assume? So if it is an employee, there will be some minimum age constraint for every employee, right? It can be some 20 years old or some 16 years old, and some maximum retirement age will be there, say some 70, like that. So in that case I can say that this age attribute is supposed to have value from so it should be an integer also, right? So you are not supposed to keep any float value for that. So it's something like the data type, right? So it can have any integer from 16 to 70, so like that, or some other constraint you can impose. So that is the value set or the domain of that particular attribute, say age. Similarly, if you are looking at another attribute, say name of an employee, some character string you can expect there. So if you want, you can restrict the maximum number of characters in that, like that. Okay, so like that, salary, anything you take, there will be a set of possible values that we can assign to this particular attribute, and that possible set of values together is what we call as the domain of that particular attribute or the value set of the attribute. Okay, now let's read it. Each symbol attribute of an entity type is associated with a value set or a domain. So right, which specifies a set of all possible values that may be assigned to that attribute for each individual entity. For example, this age itself we can remember as an example. It can be minimum age and maximum age. So you can say that the domain of the attribute age attribute, the domain is like any integer from 16 to 17. This is one example. You can give a different example also. Yeah, that about it. Yes, so that about the value set. And similarly, if you are looking at the name attribute, you can say like the set of all strings of alphabetic characters separated by say some blank character can be thought of as the what called the domain of that name attribute. So like that, for any attribute you can define it. And this value sets we are not typically displayed in the ER diagram. If you look at the ER diagram, in the final diagram, entity, relation, attributes, everything we will represent multivariate attribute notations we are having. But what about the value set of all possible values of that we are not going to represent? So that is understood, that should be there as part of the specification. It will be there. So it is something like so we are not typically, so if you want you can represent, but typically we are not going to represent this value set. And it is similar to our data type, right? So sometimes this age, salary, they are all set of all integers, like that, string for name, address, etc. Sometimes something like a true or false value you may keep, like, right? So boolean value, it can be float or it can be enumerated, like that. Any data type kind of thing you can use as the value set or the domain of any particular attribute. Additional data types to represent the common data types such as date, time, and other concepts are also possible. Right, the mathematical interpretation, if you are looking at mathematically, an attribute A of an entity set E. So just look at the notations. A is the attribute, okay, and E is the entity set. So E is a set. So just look at this this mapping. Okay, so what we are trying to say is an attribute is basically a mapping from the entity set to the power set of the value set. Okay, so you know what is power set from set theory. You know what is power set of all subsets of a given set. So capital V is your domain or the value set. Okay, so this capital V is your domain or value set. So it is a set, value set. So what is P of V? P of V is the power set of V. So what is power set? Set of all subsets. Set of all subsets of So all possible subsets will be there. So any attribute, if you are seeing, it is basically trying to map an entity that is containing all possible value to a particular power set, I mean a subset of this value set. Okay, so hope this notation is clear. So you can think about it. So already you know what is mapping, what is power set, and try to visualize what this mathematical argument is trying to say. So we refer to the value of an attribute A for, so this is another notation for an entity E. An attribute A is having a value that is denoted by A of E. Okay, and the previous definition covers a single valued, multi-valued attribute as well as nulls. Why? How it is covering? So by default, so if it is a single valued attribute, you can see that this power set is containing all subsets. Out of that, all singleton subsets I will be considering. So if it is a single valued attribute, this mapping is actually trying to map an entity to a subset of V, and that subset is nothing but a singleton set. Singleton set in the sense it is having a single value. So that is a single valued attribute, right? Now if we are mapping to something other than singleton set, it is a multi-valued attribute. Now this power set is even containing the empty set, saying that the attribute value is null. So if the attribute value is null, then this entity you will be mapping to an empty set corresponding to that attribute. If it is a single valued attribute, that entity you will be mapping to a singleton set from that P of V. If it is a multi-valued attribute, you will be mapping it to a subset which is containing more than one element, right? Now this is slightly another little bit complex in the sense, if it is a complex attribute, you know, that attribute is further divided into small parts, right, where there will be different value set for different subpart of the attribute. So v1 is the first subpart is containing a domain, having a domain v1. Second subpart of the attribute A is having a domain v2, like that. So take the power set of all of them, like a p of v1, p of v2, etc., p of vn. In the sense, the attribute A is divided into n subparts. Okay, so the value set or the domain of each subpart is denoted by p of v1, p of v2, etc., p of vn. Now you take the Cartesian product. Okay, Cartesian product of this p of v1, p of v2, etc., p of vn. So something like this, and that Cartesian product further you take the power set, and that will be the value set for a composite attribute. So don't confuse at this point. So simply understand it as a mathematical way of representing composite attribute value set. Now you can take a small example and you can visualize yourself what does it trying to convey. And you know, mathematically you already studied in discrete mathematics class and all, what is power set and what is Cartesian product of something and what is power set of that one as a whole. So that together makes the value set for a composite attribute. That is what we are trying to say, where v1, v2, v3, etc., vn are the value set of the subparts of the given attribute. Like n, we divided into n subpart, and each subpart is having value set like v1, v2, v3. Take their power set and Cartesian product and take the power set of that will give you the value set of the composite attribute. Okay, now this is a preliminary design of an entity type for a company database. Now here there is no notation for the relationship and all. Simply in the so hope you remember in the first part of the video we discussed about the company database having 4 entities, that is a department entity, project entity, employee entity, and dependent entity. And now you know how to draw it pictorially. Each entity we will be representing by a rectangular box. Inside that we will write the name of that particular entity. So this is department entity, and each attribute we will represent in this oval shape, like a name of the department, number, and all. And this underline corresponds to the key attribute, and this double oval corresponds to multi-valued attribute. Okay, and the start date of the manager, like that. Any information you want, you can represent. This is project, location of the project. And we all hope you remember the project is supposed to have a single location, where department can have multiple location. That is why here the location attribute is multi-valued, here the location attribute is single valued. This specification we explained in the first part of the video. So that common example we are considering. Okay, and name of the project, number of the project, some unique number and all, and these things are found to be unique. Controlling department also we are keeping. In employee there are many things like name of the employee, that itself is a composite attribute containing first name, middle name, and last name. Some key attributes, social security number, sex, salary, works on, this particular employee is working on a number of projects, that is why it is a multi-valued attribute. And also in each project how many hours the employee is supposed to work, I mean the employee is working in a week, that also we will keep track. And what about the supervisor of this employee, and what about his address of the employee, birth date, in which department he works, like that all this attribute information you can keep. And now the last one is about the dependent information. Every employee is having some set of dependents, right? So the birth date of the dependent, sex, employee, dependent name, relationship, how he is related. Now here you can observe something called, here there is no key attribute, right? So no attribute is having some underline like that. So here this is a key attribute, right? Here this is a key attribute, and here this is a key attribute, this is also key attribute, like that. But in this last one there is no key attribute. So such entities are what we call as weak entity. Okay, so this dependent is bound to be a weak entity, and how we are dealing with the weak entity we will see in our upcoming video lectures. Okay, so hope you get an idea about the also. So here we discussed mainly this value set, concept of value set and domain. And finally this is a conclusion, like how we are drawing the ER diagram. But this is not the complete diagram. Now we have to define the relationship, so that only completes this diagram, how these entities are related to each other. Then you can draw the final diagram. So before that, this is the first stepping stone, like you have to draw the entity, attribute, those things, and then you will identify the relationship, and all together it makes a complete ER diagram. So the relationship type, relationship instance, constraints, etc., we will explore in our upcoming sessions. Yeah, thanks for watching.